Hi guys, this is the first video of a series I'm gonna try to make about control rig in Unreal, but I'm gonna try to use an approach where, instead of learning directly in Unreal, I'm speaking to people that come from standard ECC application. I've been a rigger for almost 2 decades now. I've been playing around with 3ds Max, XSI, Blender and Maya. So the rigging concept that I'm going to try to show here are pretty much common across the board. I'm going to use Maya simply because I'm more proficient with it, but I'm hoping that this is kind of a introduction / translation into what is control rig. So control rig I got really excited when control rig was announced. The reason being, it seems like it encapsulates everything that a standard ECC application based on old architecture is not able to provide. Now, I may be wrong in here, so I'm very new to control rig. So if I make any mistake, please correct me. So what is control rig? I'm going to try to explain it with my own words, the way I did it in my brain when I was trying to convert my knowledge into the Unreal knowledge. So what is control rig? The answer is exactly in the name. And what I mean by that is a rig in a standard industry is usually a combination, it's the sum of 3 different things. There is the kinematics graph, there is the deformation graph, and there is the geometry that is deformed, the vertices are deformed by the deformation graph. Now, a standard rig is nothing else than creating a relationship between a bunch of matrices, float values, etc. that are driving the deformation graph, and the deformation graph has a relationship, usually a weighted relationship to the geometry. Okay, so the kinematics graph is usually manipulated in terms of UI and interface through a series of controls. You've probably seen them around. There are NURBS curves or yellow, red, blue controls that manipulated in a certain way. They are manipulating the kinematics. The kinematics have a relationship with the deformation, and the deformation in the end has a series of rules to deform and move the geometry. So in a standard ECC application such as Maya, usually I always say that 95% of the time a rigger spends rigging the rig rather than rigging the character. And what I mean by that is that in order to achieve complex results and still provide a nice control interface to the animator, we spend a lot of time trying to make sure that a control follows in the right space and stuff like that, rather than actually focusing more on the quality of the deformation. So my experience is that most of the time we spend most time rigging the kinematics graph, rather than rigging the deformation graph. And that's something that control rig, I think, is trying to solve as well. So what control rig is, it's really nice, because these two things in a normal, if you start rigging and you follow any tutorial, usually these two things in a Maya environment, for example, these two things are kind of interconnected. There is a lot of interdependency between the kinematics graph and the controls. And when you start building more experience, the more you build rigs, the more you understand that you should decouple these two very quickly. You should try and keep the control rig separated from the kinematic graph. So control rig, it's something that basically is not trying to solve anything that is related to this area here. It does not provide you any deformation API. It does not provide you a way to interact with the relationship between the geometry and the deformation graph. So in Unreal, now we are in a situation where everything seems to be really nice and really decoupled. And what I mean by decoupled is that each individual process, deformation, geometry, it's on its own. And because of that, you can build a really modular system where you can mix and match and swap rigs and skeletons. So this is the most abstract thing I can think of in order to explain control rig. But if we have a series of controls in Maya that are moving a series of joints, and the joints are associated with a geometry, the joints are associated with a skin cluster deformer, which it's deforming a geometry. If I translate those words into Unreal, this is a skeleton in Unreal. This is what they call skeletal mesh. So the skeletal mesh is it's a combination of the geometry description plus the relationship and the weight deformer that are assigned to be a skin cluster to a skeleton. I don't know if the name of the Unreal deformer is actually skin cluster, but it's the same. It's a linear skin deformer. Of course, we're talking about also blend shapes, but in this specific instance, we don't really care. So, how do these joints move? Basically, these joints usually are moved by a series of operations that the rigger makes, and we're going to call those atomic operation solvers. So, the controls are the interface to the animator. These controls are arranged and hooked up in a certain way to manipulate solver input data, and the solvers are outputting matrices that are driving the joints. So this is where control rigs comes into play. Okay. So what got really why I'm so excited about control rig? There are many things, but the first why I think is good, why I think is awesome. The main reason, there are different reasons. The first one is that the graph in control rig is compiled, which means it takes the compiler at a compilation time. The compiler takes care of breaking down all the static data that usually sits around in software like Maya, where you'd never compile the graph. Also, compilation provides you a performance boost. So that got me really excited. The second reason is the event stack, and this is a big one. So the event stack, it's completely different from how a software like Maya works, where you traverse a graph in order to get a value. You have a graph and because of this, it's not really suggested and is actually going to break things if in this graph you create some sort of loop, okay, where you're trying to drive control B from control A, and then once the control B position has been updated through control A, you're trying to drive the control A position through control B. You cannot do that. We're going to see that in Maya in a minute, what I mean by that, by using a constraint example. In Unreal and control rig, the operations in the graph that you set up are actually executed one after another. So order of operation is important. But this means that I can say control A drives control B, and by control I mean any transform or anything. Transform B, transform A. Once that's done, transfer B is in a new position. Then you can jump into another portion, and this is done. This is an execution stack. It's like a history in Photoshop. When this is done, nothing stops you to say, okay, now to transform B position, apply that transformation to transform A. This is very different compared to what we're used to software like Maya in rigging. And because of that, this is where the riggers spend most of their time trying to rig the rig rather than rig the character. This is what I mean, is like most of the time you're trying to get a control in the right space simply because it's more convenient for the animator. So we end up complicating the graph quite a bit. The other thing that got me really excited is the setup event, the backward solve, in the variables. So the setup event, it's something that allows you, it exists and it runs before the rig gets evaluated, and it allows you to specify is the init of the class control rig if you want, or is a construction script or a blueprint actor. You can initialize variables, values, all the static values there, but also make your rig modular in a way that it can adapt to any new skeleton. We're going to see that in another video, or maybe at the end of this one. The backward solve, it's basically a very nice implementation of what in the industry is known as a mocap remap rig, where usually we say the controls drives the bones. And then what we do in the industry normally is that if you have mocap as an input, let's say, the mocap goes directly to bones. What you want usually is convert that animation on the bones onto controls. So what you end up doing is an invert rig. It's a rig that where the bones are driving the controls, and then you bake the animation on the controls. So the backward solve does exactly that. And that's why it's backward, basically, where you can assume that any input animation that is happening on the bones, that can be an animation clip or a motion capture or a live link session, it's transferring data to the bones, and then what you want is bake that data back into control, so you can offset the animation on those controls using animation standard workflow. And the other thing that got me really excited, they clean up the variable system, where you can store, access, and load the variables like any other blueprint. And if you use the control rig component in a blueprint actor, you can access those variables. That's really awesome. So this is me trying to translate what I know in rigging inside the new control rig era. So let's look at Maya for a minute. Let's go back to Maya for a minute. So in Maya, I'm going to create two spheres. And these spheres, let me delete the history on it, so it's a clean slate. I have these two spheres, and I want to say that when I move this, I move that. Okay, there are many ways to do that, and the first foremost is hierarchy. Concept of hierarchy. This is child of this parent. I move the parent. I move the child. This hierarchy exists in control rig as well. Usually it's the skeleton hierarchy and the control hierarchy, but Unreal is really nice because they do an import of the skeleton. They also allow you to create virtual bones or virtual transforms inside the control rig graph. So if you need any new spaces, etc., but we're going to talk about that later. So this is the first option. The second option that you have in order to connect things is direct connection. So if I take this transform and I say drive this translation to this with this translation, you can see that the two things are on top of one another. And the reason is I'm connecting directly these three values to these three values. So this sphere 2 now it's it's exactly on top of sphere 1. Because these values here in Maya represent the local space of the object, of the transform we're moving. Which means if I create a parent, so I'm grouping, and I move the parent, the local space of these values stays exactly the same, but it's now multiplied by the parent matrix. So if I move this up by 1 unit, so z is up 1, this z is up 1, but it has an offset, and this offset is represented by this transformation. Okay. So one cool thing that Unreal did is that usually in Maya, before they added the offset matrix inside the transform node, this is relatively a recent thing, but in a standard normal for decades, in order to do this kind of mechanism, you had to add a group above to represent a new Euler coordinate. So, but this kind of stuff, you can do it without having adding an additional space. And the reason is that they recently added the offset control, offset transform, within the transform node itself. We're going to see what that means. Let's keep going with that, with this. So let me disconnect this thing. So we saw the hierarchy, you know, parent-child relationship, parent-child relationship. We saw the direct connection. The last one, probably one of the simplest, is by using a constraint. Now, this object drives this object through a constraint. And now it's time for us to look at the graph. So the graph says, you can read it like that, says that polysphere 1 is the master of polysphere 2 through parent constraint. So we can say that this drives that. Okay, this is what you cannot do in Maya. Now say something that is called a bidirectional constraint. You can say without writing custom code, that should be said. If I now say polysphere 2 drives polysphere 1, something weird happens. The first thing that happened is that Maya is throwing you an error, is saying there is a cycle, because that is a cycle. So we are saying that polysphere 1 position is driven by polysphere 2 position, a polysphere 2 position is driven by polysphere 1 position. And this is the result. If I take polysphere 1, something, you know, weird happened. Because this graph, yeah, it's a graph, and in Unreal this does not happen because the operation are in an event stack. That's why it got me really excited. So I'm gonna try to build something now really quick so we can jump into Unreal. So let me create 2 bones. Let me actually scale those 2 bones up to 10. Let me freeze scale on it. So we have 2 bones. Let me display, animation, joint size. I want the joint size to 1. Great. Okay, so I have 2 bones. I'm going to create a sphere, cube. I would say I can combine those. I'm going to delete the history on it. I'm going to call this direct G-code. Let me direct 110. We're naming. And then I'm going to select these 2 objects and bind skin. This is not a rigging tutorial in Maya, so I'm not going to explain exactly what I'm doing. So, let me paint a little bit of weights there. Bear with me. So what I'm doing here is basically assigned the sphere completely to the first bone and the cube completely to the second bone. And I have not done that because I made a mistake. Classic. Well, that's good. There we go. So yeah, so we have this amazing rig. This is the best rig I ever created. Let's see how we do this. Let's tackle a bit of initial concepts in control rig. So what I'm going to do is I'm going to export this as a SKM direct solver direct, and let's jump into Unreal. Let's create a new folder here. Ooh, that's a spoiler for the next video. Let's call it direct. Inside here I'm going to import the FBX, which is probably inside here. No, my data. Nothing. Yeah, I'm not going to create any material for it. Yeah, let me get rid of that. Open it. Let me get rid of the physical asset. I don't need it. And let me delete that. I'm just trying to keep this folder clean for this purpose. So the way you run control rig is that you enable the plugin called control rig. So enable, you reboot. What you can do now is you can build a control rig from a skeletal mesh, and it creates this new node. Awesome. So in here, it's the Unreal has imported the skeleton. This is not a direct reference, and this is beautiful because it means that we can put things inside this hierarchy, like a new space, a new virtual bone, or a new control, and it won't break the original skeleton. And so this is amazing. Right now we have the geometry, which is the skeletal mesh, and the imported hierarchy of bones. Let's analyze a bit the three events I was talking about. There is the setup event, and again I'm referring to this as a Python init of a class of an object Python, or a construction script for a classic actor blueprint. Then we have the forward solve, and then we have the backward solve. So these are the three main events. Setup event is what in a standard modular rigging system you call like guides, or initialization pass. In the setup event, you can set up this runs before this one. This one is the main control rig functionality, so it's a direct manipulation of the controls. The controls drive the skeleton through solvers, and then the skeleton drives the geometry. The backward solve, it's triggered on demand, and it basically does the opposite of the forward solve. I take this, you specify the rules here on how to drive controls from the bones animation. Whatever the input animation is, it could be mocap, it could be anim clip, it could be standard animation or procedural animation, it doesn't really matter. So in the setup, I saw many tutorials about control rig, and one thing that happens is that what you can do here is create a new control. You take the control, you move it, and then you get close to it, and then you say you can copy and paste the transform, or you can say set I need to transfer to closest bone. Now this is really neat when you try to prototype stuff, but I personally don't really like it because most of the time this hierarchy is not that simple. There might be different joints on top of one another, oriented in a different way for some specific reason. So what I really like to do is set up the setup event immediately to define the position of this control. So this control is like direct one control, and I'm going to create another one, direct 2 control. So these are here somewhere. So what I do here is that the first thing I do is I can do two things. I can get a list of these bones, but I'm gonna do for now one by one. So I'm gonna get the transform of this bone. I'm gonna set the position of this control using this transform. You can see that the control immediately popped in the right place. And this control here, let me just grab the control. I just want to change the gizmo to box solid. No, that's too much. Box thin. And probably I have to scale this down to just the shape of it. And then I just changed the shape. So this control here, every time I open or I initialize a control rig, this will run. So you can imagine that if you want to copy this control rig to another character, if this character has the same bones names, or even if it doesn't, there is a way. We're going to show that in a different video. Because you will get the snapping automatically. So it's really good for you to define the setup event at the very beginning. So you get a lot of work done for free. So the second thing is the second control and the second get transform and that. Now this is the setup event, and that's really cool and really neat. But one thing I've done wrong here on purpose is that now this control here at the very beginning has transforms values. So the location of its current transform is at -40, and usually this being a control, you want the starting position to be at 0 for the animator to make sense through the animation curves. So rather than doing set transform control and set transform control, another note that you can do is you can say control offset, and I don't want that, but not in the forward solve here, so ignore me. So I can pick direct one control and have this here, and something weird happened. I'm doing this on purpose just because I never saw this done in a tutorial, and this is something I just wanted to explain. So what happened is that this control already had stored offset values, and it moved, and then before compiling, this control had also the offset stored on the offset. So if I get rid of that now, and if I select now this object here, you can see that the offset transfer is at 0, and this happens because it's at the origin. This is the world position, but the current transform, the actual values that you will animate, are at 0, which is really nice. Let's see what happens when I do the same thing. So let me duplicate this node and change for this direct thing. See what happens here. So if I select control number 2, you can see that because this is 40 units away from the origin, the world transformation value of the parent transform, which is called control offset, it's 40 units away. But the local space of the control, which what you actually animate, is at 0. Let me turn this as well into let's make a octagon thin. No, let's do another box thin, and let's do a smaller one. Awesome. Oh my god, couldn't be more precise. Really? Okay. Oh yeah, of course I scaled by 10 units in mine. Okay, so this is amazing, but the rig does nothing. This is just a setup event. So another way you can do this, this would work, but one way I like to do these things from the very beginning is by making this graph a little bit more modular. And what I mean by that is that I would want this graph to work even if, the joint name was different. So tell you what, we're going to do that in a different solver because it will make more sense. I apologize, but I'm gonna jump straight into the forward solve. Otherwise, I don't want to complicate two things. This is just the first video. So okay, we have this position, and now it's time to actually rig the things. And it happens that to rig this thing, it's actually very simple. You want to do basically the opposite. You want to get the control position. You want to set the transform of the bone. And now what you should get is that the bone moves with the control. You do the same thing. I don't know why it does that every now and then. Fine. So, and that's what you have. So this is what would you do if you wanted these two to be in hierarchy? Now you have to make a choice here. You want to have this hierarchy to be flat and then drive the offset transfer with certain rules, or you can simply parent this underneath this guy and compile again. So what you get is the same behavior as in Maya, but rather than creating it through the graph, you are creating through the hierarchy. In Maya, this distinction is called DG and DAG, so a direct acyclic graph and a graph per se. So basically, one is the outliner. This is your Maya outliner, and this is your hypergraph. So I'm hoping that this. So this is. I know what. It's a very long video to explain just a couple of things, but this is what took me a little bit longer because things are named differently. And you know, the idea behind it's so powerful that any rigger needs to rethink a little bit more about rigging, because there is stuff in here that you can do that were simply not possible in standard DCC application due to the architecture of the graph, and that's really exciting. The backward solve, it's very similar to what you would do in a setup, in a very simple setup event. So, but in this case, instead of using the control offset, you want to use the control itself. So set control, compile. So now you know that when you're performing a backward solve, the bone position that has anim on it will drive the control position, and this bone position will drive the control position. At that time, then you can bake the animation on the controls, and boom, you have your mocap remapped onto your control rig. I'm gonna stop the video here. The next one will be a little bit more interesting, I promise.